I will now introduce the next panelists coming up on stage, ladies and gentlemen. We'll be hearing several presentations from A-Star and the Singapore Battery Consortium. Joining Anurag would be Dr. Muhammad Asfar Ramli, Deputy Director, Systems Science Department, Institute of High Performance Computing, A-Star. Dr. Koh Leong Hai, Program Director, Smart Grid and Power Electronics Consortium, Singapore. And Dr. Debbie Chong, Deputy Director, Singapore Battery Consortium. They'll be making their way up right now on stage. All right, and again, moderating the session, ladies and gentlemen, for those of you online who've just joined us, is Anurag Chatterjee, Head of Sales for Renewables and Power Asia Pacific Energy Systems, DNV. Anurag, over to you again.
Thank you. Thank you. Morning, gentlemen. Dr. Ramli, maybe can I invite you to the podium to start with your presentation? Thank you.
Very good morning. I would like to first thank A-Star and EMA for inviting me to share during today's Energy Insight session. So my name is Asfar. I'm the Deputy Director for the System Science Department of the A-Star's Institute of High Performance Computing. Okay, so today I'll be sharing with you on SITEM, which stands for Singapore's Integrated Transport and Energy Model. I'm the Project Manager and Co-Principal Investigator for the SITEM project. So before I go into the details of the project proper, let me first provide some background to know what this project is all about and why we are undertaking this effort. So as I believe most of the attendees are aware, Singapore government has set a target for all road vehicles to run on cleaner energy by 2040, a significant emphasis on increasing the total number of electrified vehicles. So government also publicly announced a target for 60,000 EV chargers to be rolled out island-wide by 2030. So it is broad and ambitious targets in place, so various policy and planning questions need to be answered. So firstly, can we really quantify the impact in terms of the transport system, in terms of the rollout of the electrified vehicles, and also on whether the electrical grid infrastructure will be adequate to support these targets as well. So, and if not, how much and where will these upgrades be required? So we also want to understand how to optimally deploy the EV chargers across the entire city in order to maximize drivers' convenience and utility whilst minimizing the impact on the grid. Okay, so it includes questions like, what is the optimal mix of EV chargers, fast and slow, by balancing the needs of different types of EVs, such as privately owned cars versus taxis and fleet-based vehicles. So finally, Singapore government understands between the present day and in 10 to 20 years' time, various different technologies and innovative concepts of charging operations have been proposed by the ecosystem, and this could potentially alleviate the need for heavy infrastructural costs. So agencies are interested to understand, can we really quantify the impact of these innovative concepts and in terms of the cost savings potential, and as well as adaptations to the local context. So with these problem statements in mind, let me introduce formally the SITEM project and the modeling framework that we have developed together with the Singapore government agencies. So the project is commissioned by the Public Sector Science and Technology Policy and Plans Office. This is a division in the Prime Minister's Office of Singapore. And the objective is to do a comprehensive impact analysis and policy recommendation study of the vehicle electrification journey of Singapore. So our team consists of data scientists, computational scientists, transport and energy modelers, simulation engineers, and even behavioral scientists from two research institutes, which is the A-Star's Institute of High Performance Computing and TUNCREATE, which is an entity funded by Singapore's National Research Foundation. So the combined team has a significant experience in building such city-scale urban modeling simulation platforms. However, I believe this is the first time that a fully integrated transport and energy framework has been attempted at city scale at this level of resolution in Singapore. So the project incorporates 4 primary modules. The first is on behavioral modeling. This covers the scope of work of determining the rules and assumptions that will utilize to model drivers' charging and movement decisions, based on relevant parameters such as the state of charge of the vehicle, as well as the driving and parking patterns. The second module is charger placement, which is optimization, involving combining geospatial data, mobility data, and we perform mathematical computational optimization. of charger placement across the entire city, with the general objective of maximizing the utility of our chargers and convenience to the drivers. Okay, so the third module is the mobility and charging simulation. We utilize high-performance simulation to model movement and charging events of multiple land transport modes across the entire island. And this takes in the inputs of the behavioral modeling and the decisions, the level of electrification of the specific scenario that we are trying to model, the number and speed of EV chargers across the city, and provide output of the energy demand, which is a key output to the model. And then we take the energy demand and feed it into the electrical grid simulation and basically aim to quantify what's the impact of this level of electrification on the grid infrastructure and provide the recommendations of the grid upgrades where necessary. So let me just give an example of a mobility demand-based charger placement procedure. So we identify the locations of the candidate sites for chargers. Okay, depending on availability of data, we can also extract the total number of parking lots within each location. Okay, we compute the amount of potential energy demand for a specific electrification level by using available mobility data, such as volume of traffic, parking events, and the expected mileage that they are expected to incur. Okay, so based on this energy demand, for different locations, the mix of vehicle types, the total charger count for the specific scenario, we can then distribute the number of chargers of different speeds to every single location. So I've shared actually is a relatively simplified description of the methodology. Of course, we can actually perform more advanced optimization procedures, balancing multiple conflicting objectives, maintaining various constraints. But of course, it depends on the objective or the optimization problem that's being formulated. Okay, so next, let me share with you the transport modeling simulation platform that we utilize for this project. Okay, the platform is called CityMOS, and it's developed by our team members from Tomb Create. CityMOS is a microscopic agent-based simulation. Okay, all the vehicles are modeled as individual entities. Agents are given travel plans to move from point to point and interact with each other through the road network infrastructure. So CityMOS was designed with specific features to model electric vehicles. Okay, it incorporates realistic features of vehicle energy efficiency, and it's also designed to incorporate communication interface that enables seamless coupling and integration with an energy distribution simulator. So it has realistic traffic dynamics, congestion and queuing, and is able to model different modes of road transport, such as private cars, taxis, private hire cars, and public buses in very high detail. Okay, so the simulated EV charging demand is then fed into a grid simulation model. It's used that is built using a simulation software called Mesmo. Okay, so and the simulation will therefore be able to quantify the impact of the additional energy demand on the grid. So I will not be going through too much details of this because, in fact, my colleague, Dr. Desmond Chai, will actually be giving a more thorough talk and description of the grid modeling aspect of SciTem project in the next segment at 11 a.m. So do stay tuned for the next segment. Okay, so before I conclude my sharing, let me just share some of the preliminary outcomes that we have resulted from the project thus far. So I'm glad that in close collaboration with the partner government agencies, we have reviewed and validated the plans for charger rollout and grid infrastructure upgrades. And the project is still ongoing, and we are continuing to refine our model to help and improve the quantitative analysis that can be done in terms of understanding the electrification scenarios that they are looking at. So the team also validated smart charging could, in fact, have a significant impact on this ability to reduce peak energy demand. Okay, so we learned from our data analysis that average duration of cars parking at night are actually typically longer than the amount of time they actually need to charge. So by intelligently reducing power output to cars, using a smart controller, you could actually deliver more overall charging energy, have more EV chargers for the same amount of peak power. And therefore, it can be able to deliver more energy as compared to setups that do not incorporate such a smart charging controller. So lastly, as a result of this project, we have undertaken and achieved a high-fidelity model of the local grid distribution network, as will be shared in the next segment. And lastly, we are continuing our investigation of alternative concepts of operations and quantifying their potential in terms of solving peak demand problems. So let me close off by thanking our team members from the IHPC and Tomb Create, without whom project could not have met with significant success. I would also like to thank our project sponsor, the Science and Technology Policy and Plans Office, for the support as well as the coordination work with the various government agencies that we have worked closely during the course of this project. So thank you very much.
Thank you. Thank you, Dr. Ramlee. Dr. Koh, thank you.
So thanks, Dr. Asfar, for setting the scene for energy grid modeling and simulation, and as well as grid interaction modeling and simulation. So my talk will be a little bit different, where it's going to be talking about deployment, translational research that our companies in Singapore will benefit out from it. So allow me to introduce myself. My name is Leong Hai. I'm actually the Program Director for Smart Grid and Power Electronic Consortium Singapore. In short, it's called SPECS. It's actually a national consortium in Singapore focusing on translational research for companies. So I must acknowledge some of the contributor for this presentation, that is New Wai, who is actually the senior scientist on Viridium Redox energy storage system, as well as Professor Tang Yi, that works on the distributed energy system that is funded through EMA, where we deployed 10 distributed energy storage, less than 50 kilowatt hours in HDB, void decks in all different places in Singapore, as well as Dr. Koh Liang Mong for the 2.4 megawatt ESS that is deployed together with Singapore Power Group that's sitting here as well. And of course, Dr. Ding, who is an expert in hydrogen fuel cell and electrolyzer. So it's all about storage that we are talking about. But first of all, I will introduce, I think the trend, Dr. Asfar has already spoken about it. The distributed energy resources has really made decentralization that is coming possible. And it requires a more resilient and intelligent system. I think some of my colleagues earlier in the startup has talking about flexible loads, smart grids. Then the second part, of course, is solar. All right, the deployment is coming, is introducing intermittence. Can something be done about it? So one of the key areas could be advanced control. Second would be the storage. I think the 200 megawatt storage comes at a good time. I think that shows that there's a lot of insights coming from EMA that these are the right thing to do so they can handle the intermittency grid threshold. And last, of course, is also the 60,000 charger that's coming, where 40,000 are going to be in the public area. So all this requires some kind of solution for it. So my talk goes into 4 areas. I'll introduce the specs. Second, talk about Viridium Redox battery research, development to deployment. And the third is talking about comparing the distributed energy storage, or DESS, versus a centralized storage. And then I'll come to a conclusion for that. So first, let me introduce the Smart Grid and Power Electronics Consortium specs. It's basically about the academic partners. They're all here. A-STAR, NUS, SIT, SUTD. So thanks to all the 5 agencies on the bottom right. They are all sitting in the board of SPECS, as well as also in the steering committee, that the goal is really to translate all this applied research to companies. All these IPs can be adopted, and it would co-develop into a commercially viable solution for it. So we welcome you to come forward to talk about it and how we can explore together. And the 2 areas are very clearly stated. It's going to be in smart grid as well as the advanced power electronics. So we're happy to share these are all the members in the middle from the large local enterprise LLE. The one that just came recently is Capital Infrastructure that we just signed an MOU recently. That was just announced, a press release or only released yesterday. So there'll be more exciting things to work on, low carbon energy research, as well as translation research for sustainability. So, and then the second layer will be the MNC as well as the SME. So we welcome members who are interested in this to join us as well. And with that, on the right-hand side, it allows us to, for these members to reach out to more than 2,000 partners, all right, through the Singapore FinTech Association, Singapore Water Association, SEAS, etc. All right. So with that, I'll just go into a little bit on the applied research now that is called research demonstration deployment, all right, RDD. So this is actually a storyline that talks about ideas coming out for VRB, all right, which is actually highly scalable because the power and energy can be decoupled at this moment, all right. And it started off from a very small 2.5 kilowatt, 10 kilowatt hour in a laboratory, all right? And you can see the demonstration, it doesn't look very fanciful right now, right? So, but that was more than 10 years ago. So today, all right, I think when we first started to do the deployment about 5 years ago in CleanTech 1, we were proposing a 100 kilowatt hour VRB. Trust me, it was no fun, right? SCDF was not happy, NEA needs to be consulted, JTC was very apprehensive. So it took a long time to get a permit to be installed and demonstrated it. What did we try to do at that time? This is how it looks like. From the top down, the JTC has provided the solar to allow us to charge the Viridium redox battery storage, all right? And then we will power it up at night to the second level, which is the lighting load, as well as a motor load that is in level 2. And in the daytime, the storage energy can also be used to charge the autonomous vehicle, which is at level 1. And the level 6 has all the fume hood and the DC lighting from Philips that we can power all this. So this was a demonstration, thanks to the agency for funding some of this initiative, so we're able to do this demonstration. So today, the company has already taken the IPs and know-how and build up a startup company, and we are very pleased to share that they are able to supply megawatt-hour Viridium redox battery to a Japanese company right now. So they are getting busy. I think very similar to the Shell startup group that was talking about how IP can be translated for commercialization projects. So this company is now in that state that is ready to raise more funding in that area because business is coming in. Now, the second part I will talk about is a little bit more towards now demonstration now, comparing between the distributed energy storage at the distribution grid versus the centralized storage at the substation at 22 kV. I saw some slide that Dr. Asfar was talking about, all right? So this is actually the project that was funded by Energy Market Authority. Thanks to that, that was at least about 4 years ago, taking the initiative to say, okay, can we go to 10 different places in the HDB void deck at a distributed manner, put all this storage in and bring all the information back. So all the solars are going to be all over the rooftop, but you can put storage safely at the void deck without compromising on public safety. At the same time, you are able to help on the intermittency, et cetera, then you can have information going back to SP grid to become an aggregator, and the server will look at all this data and do some intermittency measures to mitigate the grid resiliency. All right. So with that, I will compare it against the centralized storage, which is actually the 2.4 megawatt that is installed by SP Group. This is also a project that is with our colleagues here in NTU. So with that, we would like to see whether the power system stability is better with either a grid-connected ESS or UESS, utility scale type, or a distributed energy storage system strategy. So this is one of the pictures taken from the HDB void deck. It's never going to be nice like the real thing. That's how it looks like. Small, 20 to 50 kilowatt battery rack that is grid connected. You see all the AC distribution grid in it. So, and of course, SCDF will have to sign off with this with a qualified person as well. So it's never going to be easy. It's forever going to be delay after delay because either HDB may not agree with the site or the town council may have a concern. The safety department may not be happy with the installation and the protection, the risk mitigation. So there are lots of things they've been doing for the last 4 years trying to resolve all this issue, which is non-research related. All right, but we're happy to share some of the ideas that has been demonstrated, which is actually looking at the RAM control rate, the frequency regulation as well, and the SOC regulator. There are a lot of results in this project, but I will just share maybe just 2. All right, how you can help with the intermittency management. All right. So this is a typical distribution grid that you may not be familiar. I think I see a lot of SP colleagues, but then maybe some colleagues here who are not familiar. I call it a bus number 1 to bus 18, all right? It's not the SBS bus, all right? This is the electrical bus, okay? So from bus number 1, you connect all the way to bus 18, right? That you see the numbering system. This is a typical distribution grid, how it will be lined up. At every different location at the bus point, which is actually the substation near your car park where the rubbish bin is, that is where maybe you will see either like bus 18, you will put an energy storage connection there at the void deck. Then at bus number 13, you may have PV on the ceiling or on the rooftop of the HDB. It connects to the grid. That's how it looks like here, from 1 to 18 for every different tapping point. And bus number 1 is the main substation, all right? And that is where the utility scale ESS is connected at 2.4 megawatt hour versus the smaller one, the one in orangey, the one with ES, those are the distributed energy storage. So the idea now is, where do you position your DESS? It has an impact, because if it trips, because the substation see that the solar goes up or it comes down, and it breaches the voltage security, the substation is supposed to disconnect, all right? Because it's a very tight control. We guarantee our end user that we will not be allowing the voltage to swing. And this is an example, if you can understand how it looks like from bus number 1 to 17, right? You see the voltage just keep going down, all right? And when the solar goes up, all right, which is, it will actually go up to high level and low level. You see that it can go from 1 per unit to 0.95. So that is still within the limit, because the distributed ESS is there. If it is not there, potentially you have the same old Australian scenario that it could cause trippages, because you have a long line at the distribution line. So this is an example to show that the DESS can be controlled, and provided, of course, you put it at the right point and where you couple in all the solar. The scenario may be a bit different, but it can help to provide all these trippages or blackout at the HDB, all right? And of course, you can see the data that is shown here. Having distributed ESS definitely have a better performance with a utility scale UESS. I'm not saying that it's inferior, but it can do certain things that the UESS cannot do. The second part is, since you're going to have maybe perhaps hundreds of thousands of these DESS in Singapore, can something be done about it to enhance the value, to extract monetary value out from the DESS? One area is, where do you position your SOC, state of charge of the battery? And if you look on the left-hand side, which is maximum utilization, you can only use maybe like from 50% as a base point, 90% as your frequency and a PV intermittency management, and you go down to 20. And you could actually shift it, all right, to a different base point, like 70% on the right-hand side, and you can actually participate in the frequency regulation with PV on the blue side. Then you can also play in the contingency reserve. So if you are able to aggregate this at a Singapore level with thousands of these DESS at the void deck, this could be a new business model to come up, of course, provided that EMA, the regulator, allows this to participate in it. So this is just a very simple example to say, just by shifting the base point of the SOC where you operate, you could potentially extract more economic value out from the ESS. All right. So without going too much into the detail, I would like to come to another part of it, which is a standard development organization. We need standards. All this applied research, translational research, you need to go into Singapore standards and allowing our Singapore company to do commercialization, because there needs to be codes. There needs to be certain Singapore standards that guide the company to do it in an environmental safe, as well as allow us to trade with our neighboring countries. So I can't say more that standards is important to that. So the ESS standard TR 76 is a good point to start, that we need that to help us, and that more standard be required. So NTU has taken up this standards development work organization, SDO work from Enterprise Singapore. So we look forward to more work together with SP Group, EMA, as well as ESG to work on all these standards. So the conclusion for this is, SPECS is a networking platform. Thanks to all the agency and the academic partners in IHL supporting it. And we are definitely going to make a difference in the smart grid and power electronics domain, and Unity is strength. Two is that the VRB is definitely an area to consider, even though Singapore has a space constraint, but it's definitely a lot safer, reliable, and more scalable. All right, so we need to optimize that to apply that within Singapore. All right. And DESS is potentially another area to consider, how to handle intermittency, and especially when the point where you're going to start importing energy. Are we going to do UESS, DESS, the combination? We need to use all this together, and knowing how to help our startups especially, maybe of course our LLE included, how to use the SOC point to extract business case out of it. From the time before you even install, the whole lifetime of the ESS should already be considered, which is the multi-service opportunity for ESS. And the last point is definitely SPECS look forward to strengthen companies to provide them with innovative solution, translating all this know-how and working together with them for Singapore standards to allow us to do more trading. Thank you. All right.
Thank you.
Hi, good morning. So really want to thank the organizer for bringing us here. I think we've been talking to each other for a year online, so it's good to see you all together. I'm David Chong from the Singapore Battery Consortium. I'm the Deputy Director there. So I think the theme this morning in the discussion is actually about connectivity. And I think my friends here have shared different aspects of connectivity. And it's really an area that is critical for our transition to the next, to the green transition, the next energy transition. And why is connectivity so important? Because we're talking about, as you can see, different renewables, the integration and the connection of all these new systems into our energy mix. So as we can see from the digital connectivity, the integration and the optimization is really key when it comes to systems like that. So therefore, we need this focus on connectivity. And just to do a quick introduction, the Singapore Battery Consortium was set up in 2019, the end of 2019. So just before the pandemic, so that was really challenging because I think most of the activities that we have hosted and organized are online after the pandemic has started. So, but even so, after more than a year, we have 32 members from MNCs, SMEs, and startup companies in Singapore, and we have also all the academic members from the university and research centers within the consortium. And the consortium, like what Marcus has shared, we are sister consortium. The main focus is on catalyzing collaboration and working together between the public researchers and also the industry, the companies. And so it is, with this purpose that we set up. And on this battery consortium, we have companies working on materials, battery materials, cell production, modules and pack design, and definitely recycling, and also companies in the integration end of all these technology. So I think the main motivation of having this was, like what I shared earlier, to catalyze the interaction. But as we go along, I think we see it's really critical to have a platform like this. So with the universities, we understand the individual capabilities of all the researchers, and there's so much that Singapore scientists and researchers got to offer. And we also see the business cases of all the companies in our Singapore landscape and what is needed. And so it is through this coordination of all these partners that I think very good outcome can be expected. So as you can see on this slide, it's all hands on deck, right? So when we're talking about this transition and how connectivity can contribute to it, we need the industry, the government, and also the universities and research institute to work closely together. I think the SPECS Consortium is an example. The Battery Consortium is another example of how this can come about. So with the industry, we have coordinated some of the government grant calls. We brought the companies and the research parties together. And also we provided insights with information from think tanks and disseminated this information through newsletters. And also during this pandemic, we have actually miraculously organize a local conference, co-organize a local conference for our member company to attend, and also lots and lots of webinars, to update the companies of the latest thinking and information. So I think this is what we've brought to the industry. Working with the government side, the agencies, I think in 2019, we have a white paper on energy storage in Singapore with EMA and NTU. And last year, we actually had a paper on repurposing, battery repurposing. The paper was available exclusively for the members last year, but I think we'll put it out for everyone starting from this year, so you can look for it on our website. And currently, this year, we also had a study on cathode active materials. That's done with A*STAR and EDB. Yeah. So we also had our members work with the government agencies on TR77. That's really important for the integration of ESS in Singapore. And for TC21, the technical committee, we also try to push for Singapore to be part of the participating members. Yeah. So these are some of the key aspects that we work for industry and government. For the research centers, I think we're looking at positioning ourselves in very focused areas, especially in the ESS area, on what to expect, that's coming in the coming years. Because in this area of energy transition, everything is fast-moving pieces. We're looking at a battery innovation center and also battery testing facilities and battery remanufacturing methodologies. Also, there are demand for pilot lines for battery cells, because new battery chemistries can be developed, even though the large-scale production can be overseas, but we can always look at innovation over here. And of course, recycling and handling of especially the EV batteries in the future, and how we could potentially leverage on these also, as part of the energy mix in Singapore. So these are all the different pieces that we are looking at with the Battery Consortium. And why is this important? I think, connectivity, of course, it can be a technology connectivity, but when it comes to energy, which is something closely related to all of us, the human connectivity aspect is really key. And that's how it can be the basis for all the other aspects of connectivity. I think just now in a chat with Richard and Ralph, a very good example is that as we are transiting into the green energy, we're talking about a plane that is fully efficient in the Singapore's case, and we are actually modifying it to suit the new advances, and that requires a lot of coordination, and that's why this platform where people connect and share and update and brainstorm is critical for this purpose. And I would give an example, like if we look at the need for the guidelines from the EMA is like the captain of the plane, and you're refueling on flight, right? So you have to tell the other parts of the pieces to coordinate to make such a detailed execution, because in every country the need is different. Like if you are in some countries, you see big LNG tanks, next to places where there's dense population. But personally, in Singapore, if you ask me, if you have a chimney emitting steam next to my house, I will be I'll be worried. So the appetite for risk is different in different countries. And I think what's important in this transition is that we can develop a model that is scalable, that is replicable, and that can be something very valuable, when we bring these systems overseas. Just now I mentioned that we're working on cathode active material. So in this study with EDB, basically we identified which are the big players in the cathode material space, and also in Singapore, which are the research focuses. So we have people working on sodium vanadium cathode that is not flammable, and also high capacity cathode using core shell encapsulation. And we also have research group looking at recycling technology, where high amount of lithium can be extracted. And lastly, also like a nanosheets approach in the cathode material to enhance the charging process. So in the study, we look at how Singapore can possibly play a part in this, and how we can possibly attract these bigger players to set up their facilities in Singapore, and that can be another industry in the future, especially when the EVs are here. So look out for that. We will have that information shared in the future. Going forward, I think probably that would be an area of interest also in the future, is that with the influx of the EV batteries, that would really change the energy landscape in Singapore. And how do we look at all the different possibilities? Like just now it was mentioned, the V2G, and also the second life use of all these batteries, how we could actually optimize the recycling process. Like this battery could be designed in a different way so that it can be taken apart. The different testings, processes, and also certification required. And all these are all business opportunities, I think, to the companies. And so the consortium and arenas like this, where people come together, is where we can actually unlock all these possibilities and see what are the investments that we need to put in for the research, and what are the new business models that can be developed. So on a smaller scale, like the consortium play a part, and on a bigger scale, like this conference, these are really avenues that are critical for the connectivity to occur. So just briefly, in this space, we're looking at battery materials and cells development, creating the value chain, and also definitely on the reuse and recycling. We have companies working on, in the consortium on the refurbishing of batteries. But then again, we have to look at what is the optimal way of rolling this out, and how many recycling companies can possibly benefit from our ecosystem in Singapore. And also the pack and modules designer, how we could actually play a part in this exciting new field. So these are the areas that we hope that we can continue the conversation in the coming years. Yeah. So I think in short, really, the Battery Consortium and also the SPECS Consortium, I think we are platforms in which the companies, the government, and also the researchers can really come together and look at all the key areas in which we should invest in, and therefore, aid the transition to the future energy system. Yeah, thank you. That's all.
Thank you, gentlemen, for the session, and it's really heartwarming to see there's so much going on, and there's so much we are contributing towards the whole green plan that is kind of the center of the discussion here. So this year, DNV they launched this energy transition outlook where we kind of predicted that there will be a huge rapid transition towards EV. And we do see the takeover from the combustion vehicles kind of peaking off around 2048 to 2050. And it is going to be, of course, going to be contributed towards the population growth and the raise in income per capita and so on. And then we concluded that there will be hence growth in the manufacturing and transport sector. What I liked in your presentation, Dr. Ramli, is that you are developing the SciTem, the platform, to really study the behavior of the consumers, and perhaps maybe you can just highlight a little bit about the handling of this big data that you are doing on this platform, and what are the challenges that you see coming from this integration of and the collection of the data onto the SciTem platform.
Yeah, okay, so just to answer, so I think Singapore has made a lot of investments in traffic monitoring systems, public transport information systems. Yep. So there's this on the transport side, parking sort of monitoring. Also in the energy side, there's lots of data on energy monitoring, the infrastructure, the grid network connections. There's also lots extensive database of geospatial data. Okay, so some of the challenges, of course, to model such a large-scale system at high fidelity is being able to manage. So you need advanced data analytics, AI, being able to process the data into forms that are actually usable for modeling and simulation. The scientists have to identify data gaps, okay, and we actually have to work closely with the domain owners because to really understand the dynamics of the system, okay, and to use high performance simulation because you would want your useful outputs to come out in a reasonable amount of time rather than to have simulations running for extended periods of time and you are unable to deliver your simulation results. So I guess there's lots of technical challenges with fusing significantly a lot of data sets. So the modelers need to really focus and identify. No model will model every single thing, every single physical feature of the system.
Yep.
So you need to identify the critical features, and calibrate the model and be able to provide the results in a reasonable manner.
Yep. Thank you. Thanks for that, Dr. Chong. Maybe the next question towards you. In this part of the world, Australia is kind of leading the pack in terms of the uptake of the ESS and in terms of the connectivity and the technology. ARENA launched their battery performance safety standards. It was also formed on the consortium from the academics and the regulators and some of the other stakeholders. You briefly talked about it in terms of the policy and the standards that are being developed. Could you maybe touch upon a little bit more, and when can we see this kind of develop and the roadmap ahead for the standard development?
Yeah, I think that's a really good question. Thanks. Standards development in Singapore is definitely a focus area.
Yep.
Because like this year we have launched, Enterprise Singapore has launched the TR77, and that gives the information about installation of ESS in Singapore, what are the things to look out for. And there are many areas in batteries when it comes to, like what mentioned, possibly V2G and all these aspects where it's new to our system. So the conversation has to go on. In fact, for the Battery Consortium, what we have done for this year was we have organized a series of webinars with Underwriters Laboratory to share with us on the different aspects like ESS, the transportation of batteries, also the small PMDs as well, and also on recycling. So the different areas in which we can build up the different possibilities through standards as a guideline. So that is the why it's so important that we, and definitely something that we are focusing on for the next few
Great.
coming years.
Thanks,
Yeah.
thanks for that. And it's a really important thing to have to really scale up the operations for our country. Maybe the last question. I know we're a little bit over time, so because there's so much happening in in this space, but it's good to hear from you as well, Dr. Koh. There are a lot of talks about electricity imports into the grid. I do see a lot of partners that have come on board this consortium. So maybe perhaps what's in it really for the suppliers and the partners, looking at this little crystal ball 5 years, 10 years from now, and how can they be ready to kind of be ready to embrace this technology and the new norm per se?
Okay. I think my perspective is, I think the public-private partnership, that's been an important aspect to build up a relationship that closely put this community together that Davey has elaborated quite a bit, so that the industry, the academia, and the agencies get together to do certain meaningful, focused projects that can demonstrate that. And the second part is we need a business case. All right? So you need to be economically viable. Then the partner believes that there's a business case to it, they will take it on and bring it not just for Singapore, but to the region, because Singapore is always a difficult place because the cost generally tends to be a bit higher than most of the neighboring countries. So the business case needs to be in place, the partners to be convinced, and they have enough tools to go out to the region to do all this, technology innovations, so as to bring more opportunities for the region as well. So I think in the next 5 years, 10 years, definitely it's very exciting for Singapore, because Singapore is very forward-looking, and I think the consortium is one area. The energy system modeling simulation that Dr. Asfar is talking about, these are all areas that we hope that the industries will get to know. This is a platform that allow us to share again what are the available tools that the company should be ready to do it.
Thank you. Thank you so much. And with that, I conclude this session. Thank you all for your time. Have a good day.
Thank you.
Thank you, gentlemen.